Alright, so today we are going to continue with input output redirection in C++. Alright, so what mainly we have to learn is first, before going on to this chapter, we have to know what is a buffer memory. Buffer memory is the memory that is closest to your processor, and the basic is like when you do C out, right? So instead of directly going to the screen, when you do C out, the text you want to print first goes to the buffer memory and then it goes to the screen. Similarly with Cn, instead of directly coming to your program, the input given by the user, instead of directly coming to the program, it first goes to the buffer memory and then it comes to the program, right? So the buffer memory is like a checkpoint, you can say. All right, so in C, now we are not talking about C++, we are talking about C. We could use the function freopen to redirect an existing file pointer to another stream, right? So if we want to redirect any file pointer to another stream, we could use freopen. Like for example, if you have like C out in C++ and standard output, and using standard output you actually print to the screen, but you actually want to write to the file using C out or standard output, then what you have to do, you just have to change its buffer memory, right? So the file's buffer is different, the C out's buffer is different, Cn's buffer is different, right? Your file's input buffer is different, right? So what you have to do, if you want your cout method to write to a file, you just have to change its buffer memory from cout's buffer memory to the file's buffer memory, and it will write to the file, right? We're gonna see it in action over here in this example also. Alright, so over here they are telling in C, using freopen we can redirect an buffer, right? So redirection in C++, now we can understand that changing of one buffer to another buffer is known as IO redirection in C++. So one way in C, and that also works in C++, is using freopen, right? So you tell textfile.txt, you say you open it in write mode and you pass it standard output, and what you're doing to redirect the standard output to see a text file, we could write. So what this is doing, this is redirecting standard output to textfile.txt. So whenever you will just use standard output to print something on the screen, it will not print it to the screen but actually write it to the file, as the buffer memory of standard output has been changed using freopen. So while this method is supported in C++, the article discusses another way to redirect IO streams. So C++, being an object-oriented programming language, gives us ability not only to define our own streams but also redirect standard streams, right? So we have the ability to redirect standard streams too. So thus in C++, a stream is an object whose behavior is defined by a class. A stream is an object whose behavior is defined by a class. Thus anything that behaves like a stream is also a stream. So stream is streams you call like cout, cn. When you are writing to file, that is also a stream. When you are taking statements or text from file, that is also a stream, right? So these are all streams when you are interacting with your you can say with your with features external to your program. Those are known as like streams. Like in cout, you are actually interacting with the screen. In cn, you are actually interacting like, so you are actually interacting with the user, right? So Cn is a stream that it takes in the input and gives it to the program. Cout is a stream that prints something on the screen. Your fstream is a stream, right? So you can take values from your file and you can write to a file, right? So all of these are streams when you are interacting with stuff that are not exactly part of your program, right? So you are interacting with the screen is not when you are interacting with some external object, right? The user interacting with you with your program, and using cn as a stream. When writing something to the screen, so you are interacting with the screen, that is a stream, right? So you get the point, right? What streams exactly are. So stream objects in C++ are mainly of three types: iStream. That is a stream object of this type that can only perform input operations from the stream. So to take we have been using IOStream till now, where we can perform input operations and output operations. You have iStream and OStream separately also, in which iStream you can only perform input operations from the stream, and in OStream you can only perform output operations from the stream, and IOStream can be used for both input and output operations. So all these classes as well as file stream classes derive from the classic iOS and stream buff, right? So they are derived from iOS and stream buff classes, right? So the classes, file stream classes, iStream, OStream, IOStream, all are derived from iOS and stream buff, right? So thus file stream and IOStream objects have behave very similarly. So now file stream and IOStream objects behave very similarly, right? So all stream objects also have an associated data member of class stream buff. So every stream object has a data member of class stream buff. So simply put, stream buff simply put, like a stream buff object is the buffer for the stream. So whatever your stream is, its buffer is stream buff, right? So stream buff object is basically the buffer for the stream. So when we read data from a stream, we don't read it directly from the source, but instead we read it from the buffer which is linked to the source, right? So when you are trying to read some data, at first the user, when enters the input, it goes to the buffer memory and then it comes to the program. Similarly, output operations are first performed on the buffer and then the buffer is flushed and written to the physical device when needed. So when you use cout, first the output that you want to give is goes to the buffer memory and then it goes to the screen. So C++ allows us to set the stream buffer for any stream. So what C++ allows is to set stream buffer for any stream. So the task of redirecting the stream simply reduces to changing the stream buffer associated with the stream. So to redirect the stream, you just have to change the buffer of your stream. So to use cout to actually write to a file, you just have to change cout's buffer, right? So if you want the file stream to be able to write to the screen, you just have to change the file stream's buffer, right? So thus to redirect the stream A to stream B, we need to do, so if you have a stream A and we need to redirect it to stream B, then what we need to do, we need to get the stream buffer of A and store it somewhere. We have to set the stream buffer of A to the stream buffer of B. This is essentially what you need to do. But after setting it to stream buffer of B, after after performing the operations, after setting the stream buffer of A to stream buffer of B and performing the necessary operations, if we need to reset the stream buffer of A to the previous stream buffer, we can also do that, as the previous stream buffer of A is already stored somewhere, right? So we can use the function iOS readbuff to perform below two operations. So there are two operations that we can perform using a method called readbuff. And note one thing, here the readbuff method is overloaded. Overloaded means that it can do two things. If nothing is passed to it, then it can perform some operations. If a parameter is passed to it, it will perform some other operations. So let's see, when nothing is passed to readbuff, then what happens? So it returns a pointer to the stream buffer of a stream object. So what this does, it returns the pointer to the stream buffer of the stream object. So if I say cout.readbuff, this will give us the stream buff object of cout, right? So it will give us the buffer object basically of cout. If we do cout.readbuff and pass it a buffer object of some other stream, then what will happen? It will set the stream buffer to the object pointed by P, right? So if we have cout.readbuff and we say file stream buffer over here, right? Because file stream buffer, let's take for example, file stream buffer contains our buffer of the file, right? And we say cout.readbuff file stream buffer. So what will happen? It will change the buffer of the cout stream and it will set it to file stream buffer, right? So then when you will be using cout, it will actually write to the file whose buffer was given over here. right? So this all will be very much clear from our example over here. So what we have, we are including f stream, we are including io stream, and we are including string. All right, so we have a main method where we are creating an f stream object file, right? Then we are opening cout.txt, that is a file created, right? That's an empty file, right? And we are saying out, right? ios out, so we want to give output to it, right? So we'll write to it, right? So we are opening it in write mode. Then we have string line, that is not being used in this program, right? Then we have stream buffer cout, right? That is of type stream buff, right? So it's a pointer. So stream buffer cout is equal to cout.readbuff. It returns a pointer to the stream buffer of the stream object. So this will return a pointer to the stream buffer of the stream object. So the stream object is cout, so this will actually return us the pointer to a buffer of our cout stream, right? So this will return us a pointer to the buffer of our cout stream. Then cn will return cn.readbuff. What it will do, it will return us pointer to the buffer of the cn stream. So this will return us the buffer memory pointer of the cn stream, right? And we are saving the buffer of cout and stream buffer cout, and we are saving the buffer of cn and stream buffer cn. Then we are saying stream buffer file.readbuff. So this will return us the buffer memory of the file, right? And this will give us a pointer to the buffer memory of the file, right? That is being saved in the stream buffer file variable, right? So till now readbuff, we are using this readbuff, right, where we are not passing any parameters, right? So when we do cout.readbuff stream buffer file, now over here we are passing parameters. So this is the redirection line, right? That will redirect cout to a file, right? So what this is gonna do, this is gonna do cout.readbuff, right? And we are over here saying stream buffer file. So stream buffer file is the basically the stream buffer of the file, and cout.readbuff stream buffer file will change the cout buffer to the stream buffer, right? So now whenever you will be using cout, it will actually write to the file cout.txt, right? So whenever using cout after this line, it will actually write to cout.txt, right? So this statement will write to cout.txt, and then what we're doing, we're just changing its buffer, right? So we're just changing its buffer over here back to the cout's buffer. And when we write this, now when we use cout, then what will happen, it will just write to the screen like it normally does. So over here, when setting cout's buffer to the buffer of the file, that will actually basically make cout write to the file cout.txt, but when changing it back to the cout's buffer, it will write to the screen, right? So over here what will happen, this line written to file will go to the cout.txt file, right? And this line is written to screen will come to your screen, right? Alright, so we can not run this right now, but we can edit this over here. So now one more way to make this work is, like, first let's just remove all the unnecessary part, like this. We did not need the line variable as we were not using it. We don't need the cn's read buffer, right, as we are not using it. We can remove all the comments also, right? So we can remove all the comments also, right? So over here we have this basic program where we have the cout's read buff, we have files read buffer, we are changing cout's buffer, right? We are using it, then we are changing cout's buffer back to its original buffer, and then we are using it, right? But what we could have done over here, another way to do this is by using the short the usage, right? So we could have written it like this also. So above steps can be condensed into a single step. So all these above steps can be condensed into a single step. So what we could have done over here, we could have done file dot read buff directly, right? So we did not need to save it in a file. Now we know cout.readBuff returns the buffer of this stream object. So cout's buffer will be returned, right? And cout.readBuff over here is doing the same thing. It's returning the cout's read buffer, right? Cout's buffer is being returned over here also and over here also, but over here the buffer is not being stored anywhere. So instead of returning it 2 times, we can just return it once, right? So over here what will happen, this will first returns cout's buffer, right? And it will save it into stream buffer cout, right? And then it will change it to files buffer, right? So then the cout's buffer will get changed, right? So this will work the same, right? So right now it's not running the program, but it will work the same way, right, as the program was running before with so many statements. We have just condensed it into one single statement, right? And this was our chapter for redirection of your IO redirection in C++. Now we can move on to basic input output in C++. So C++ comes with libraries that provide us with many ways for performing input and output. So there are many ways to perform input and output. So in C++, input and output are performed in the form of a sequence of bytes, or more commonly known as streams. So streams are basically sequence of bytes. So C++ input and output are performed in the form of a sequence of bytes, or more commonly known as streams, right? So input and output are performed in the form of streams, right? We have two types of streams. We have input stream and output stream. So input stream is if the direction of the flow of bytes is from the device, for example the keyboard, to the main memory, then this process is called input. So when from the keyboard your text is going to your program or to the memory, that is known as input. And output stream, it is if the direction of the flow of bytes is opposite, meaning from main memory to device or the display screen, then the process is called output. So when we have to print something from our program, then that when using cout, the text we specify actually goes first to the buffer and then to the display screen. So that is output, when it's going to the hardware, basically from main memory to the hardware. And when we are getting input from the keyboard and getting it in the program, that is the input stream. Output is when from the program it is going to the screen, right? So text is going to the screen, right? So over here we have this 4 types of methods that are for input output, basic input output methods. You have cin, right, that takes the input from the keyboard and takes it to the program, right now the arrow should have been opposite, right? So this arrow is wrong over here. The arrow should have been opposite. So what happens from cin takes input from the keyboard and it goes to the program. Cout, what will happen with the text given in the program will go to the screen. And we have 2 more methods, cerr and clog, that will also basically are output stream methods, right? Which we can use to display something on the screen, right? So we're gonna see all of these in detail: cout, clog, cerr and cin, right? So let's continue. So header files available in C++ for input output operations are: first we have IOStream. So IOStream stands for standard input output stream, right? So we have been using IOStream like since the start of everything, right? So cout, cin, all of these are part of IOStream only. So IOStream is a basic library, so it stands for standard input output stream. The header file contains definitions of objects like cin, cout, cerr, etc. So your cin, cout, cerr, clog, all of these are part of IOStream. Then we have IO manip, that stands for IO input output manipulators. So it stands for input output manipulators. The methods declared in these files are used for manipulating streams. The methods you declare in these files are used for manipulating streams, right? So like we redirected streams, similarly the methods declared in these files are used for manipulating streams. So this file contains definitions of set w, set precision, etc. that we're going to see further in the advanced course. Next we have f stream. So this header file mainly describes the file stream. So the output, input, whatever we are doing with file, that is using f stream, right? So the header file mainly describes the file stream. The header file is used to handle the data being read from a file as input, or data being written into the file as output. Alright, next we have bits std c++. So this header file includes every standard library. So this header file is very important as it includes every standard library that is there in C++. So in programming contest, using this file is a good idea. So in programming contest, you have many programming contests of C++ or other languages. So in programming contest, using this file is a good idea when you want to reduce the time wasted in doing chores. So when you need you need not include every file again and every different header file again and again. You can just include one bits std c++, and you will be able to use the methods of bits slash all the methods of every standard library, right? So when your rank is time sensitive, then mostly people in competitive programming, people prefer using bits and see this library, right? So that their time is saved, right? Because every second matters in competitive programming, right? So to know more about this header file, refer to this article. So we are gonna see all about this header file later in the course, advanced course, right? So in C++, after the header files, we often use using namespace standard. So after the header files, we often use using namespace standard. The reason behind it is that all of the standard library definitions are inside the namespace standard. So there are namespaces created in the header files, right, which classify methods of the file into different categories. Now your standard library the standard namespace in IOStream contains many methods like your cout, cin, etc., right? So when not giving using namespace standard, then before using every method you will have to define standard : so that if you don't do using namespace give using namespace standard, then you will always have to give standard : before using any method of the standard namespace. Why? Because then only it will be able to discover that method that is there in the standard namespace, as it is not there inside in the global scope of the header file, right? So as the library functions are not defined at global scope, so in order to use them, we use namespace standard. So that we don't need to write so that we do not need to write std : at every line, right? So if you want to use cout again and again, if you don't give using namespace standard, you will have to give standard : again and again before cout, cin, and all the methods that are there in the standard namespace, right? So using namespace standard, we learned about that in the basic course also. So the two instances of cout in C++ and cin in C++ of IOStream class are used very often for printing outputs and taking inputs respectively. So these are very oftenly used in programming, right? So these two are the most basic methods of taking input and printing output in C++. So to use cin and cout in C++, one must include the header file IOStream in the program. So you'll have to include IOStream in the program to use these methods cin and cout. So this article mainly discusses the objects defined in the header file IOStream like cin and cout. So discusses basically the objects defined in the header files like in the IOStream header file, like in cin and cout, right? So we're gonna see cout, we're gonna see cin, we're gonna see cerr, and we're gonna see clog in detail right now. So first we are going to see cout. So usually the standard output device is the display screen. So whenever you are using cout, usually you have to show some text on the screen, right? So the C++ cout statement is the instance of the OStream class. Cout is an instance of the OStream class that stands for output stream, right? So we saw that in the IO redirection in C++ chapter also, the OStream class, that is your output stream class, right? That gives output right? And output, basically it will send a text from program to some destination, right? So it is used to produce output on the standard output device, which is usually the display screen, right? So usually the standard output device is the display screen, and mostly cout is used to display text on the display screen. So the data needed to be displayed on the screen is inserted in the standard output stream. So the data needed to be displayed on the screen is first inserted into cout using the insertion operator. So over here what we have a char array sample geeks for geeks. We could have also made this a string, that would have been the same thing, right? And we are printing geeks for geeks, and then we are showing this string. So we'll get geeks for geeks, a computer science portal for geeks. So now this insertion operator is putting all of this text inside cout, that is our standard output stream, right? And then it will go on to the screen, the output will go on to the screen. All right. Next, in the above program, the insertion operator inserts the value of the string variable sample, right? So it inserts the value of the string variable sample, followed by the string a computer science portal for geeks in the standard output stream cout, which is then displayed on the screen, right? So it is we are also trying to print a computer science portal for geeks, right, in the standard output stream cout, which is then displayed on the screen. So this is going to the standard output stream, that is cout, and then it is displayed onto the screen. Next we have standard input stream cn. So usually the input device in a computer is the keyboard. So the input device in the computer is the keyboard. So C++ statement is the instance of the class iStream. So C++ statement is the instance of the class iStream. So cout was an instance of the class oStream. Cn is an instance of the class iStream. So and is used to read input from the standard input device, which is usually the keyboard. So it is used to read input from the standard input device, that is usually your keyboard. So the extraction operator is used along with the object cn for reading inputs. So in cout we were using the insertion operator, in cout we were using the insertion operator, and cn we were using the extraction operator. So the extraction operator extracts data from the object cn, which is entered using the keyboard, right? So this extraction operator extracts the data from the object cn, which is entered using the keyboard, right? So over here we have our main method, in which we have age, right? So we are printing enter your age to give context to the input. Then we are taking in cn, right, and using the extraction operator we are bringing the input entered by the user, and we are saving it in age, right? And then we are printing your age is, and whatever the age variable's value was entered by the user. So input was 18, and we gave the input 18, and it's showing your age is 18. So the above program asks the user to input the age. So the object cn is connected to the input device. So the cn object is connected to the input device. The age entered by the user is extracted from cn using the extraction operator, and the extracted data is then stored in the variable age present on the right side of the extraction operator. So it's present on the right side of the extraction operator. Next we have unbuffered standard error stream. So now we are on the standard error stream, but this is unbuffered, right? So we are going to see what it means. So C++ error is the standard error stream that is used to output the errors. So it's used to output the errors. This is also an instance of the IOStream class. It's also an instance of the IOStream class. As C error in C++ is unbuffered. So unbuffered means, like, yes, when you do cout, it first the text you want to print goes to the buffer memory and then to the screen. When you do cn, the first input given by the user goes to the buffer memory and then to the program, right? But over here in C error, it's unbuffered, meaning when you have to throw an error using C error, it will directly go to the screen, right? It won't stop on the buffer. It won't first go to the buffer. It is unbuffered, meaning it will directly go to the screen. So as C error in C++ is unbuffered, so it is used when one needs to display the error message immediately. So this C error will one advantage is of being it being unbuffered, that it will display the error message immediately. It does not have any buffer to store the error message and display it later. So it does not have any buffer to store the error message and display it later. Like cout has its own buffer that first the text you want to show on the screen first goes to the buffer memory and then to the screen, but C error has no buffer to store the error message and display it later. So the main difference between C error and cout comes when you would like to redirect output using cout, that gets redirected to file. If you use C error, the error does not get stored in a file, right? So in IO redirection, we saw the advantage of cout, that we could redirect the cout, right? So we could change its buffer to files buffer, right? And using cout we were actually able to write to the file, but with C error that is not the case, as it's unbuffered, meaning that you cannot actually in C error you cannot perform the redirection task that we were doing in the previous chapter. All right, so this is what unbuffered basically means. So over here is an example of C error. It will just do it will, for the user it will work normally, right? It will just directly show an error occurred, right? But it is not in the process in the background. It's not going to the buffer memory first and it's then not coming to the screen. It's directly coming onto the screen. And then we have buffered standard error stream. So C-log and C error are very similar, just the difference is that C-log is your buffered and C error is not buffered. So this is also an instance of OStream class, so it's also an instance of the OStream class, and you should display errors, but unlike C error, the error is first inserted into a buffer and is stored in the buffer until it is not fully filled or the buffer is not explicitly flushed, right? So basically they want to say is that the C-log, when you C-log something, then it's very similar to C error, but it is buffered. So first the text you want to show on the screen using C-log will go onto the buffer memory and then it will go onto the screen. So the error message will be displayed on the screen too. So we are doing C-log and error occurred. So first an error occurred is going to the buffer memory and then onto the screen, right? And we are we reached the end of the chapter. We'll continue to in the next class, and I hope you like the class.